Hello and welcome to the section 8.3 lecture today. Today we are looking at solving and graphing what we call compound inequalities. Compound inequalities are defined as multiple inequalities in a single statement. So it's a process of combining multiple inequalities, typically just two that really matter, to form just one set of solutions. The intersection is considered the set of answers that I'm going to be kind of specific to inequalities that are true, and let's go with all inequalities. Well, the union is sort of the opposite, the set of answers that are true. How do I want to say this actually? Maybe I want to flip that around. So the intersection are the set of answers that are true in all inequalities. I'm going to call the union, sorry, I didn't mean to say this, I guess. We're going to call it the combination of the multiple sets. Wow, gotta be able to spell. The multiple sets of answers. And this will make more sense after we get some context. Okay. Just hold on a second. I need to double check. I don't want to say something wrong. Okay. Then we have two other forms that kind of set all this stuff up. A conjunction. A conjunction of a compound inequality is an and statement. Where we graph the intersection. So I'm going to pull in one of those other definitions. So an and statement where we graph the intersection, and a disjunction is an or statement trying to write it quick and it's messing up, where we graph the union. All right, so we see kind of this twofold mentality. We're either going to have and statements or statements. In and statements, we graph where, I should say, where both inequalities are true. So it ends up being kind of the overlap with the intersection. And I'm going to put that on there as the overlap of the answers. And the union is, I'll put that in quotes, it's kind of an idea rather than a definition. And the union is, just as I said, the combination of answers. So, and we'll see this as we get through these. I guess this is the part that's kind of messing me up a little bit. We're zoomed in a little much. Nope, not that one. Here we go. Page width. So just to graph these inequalities really quick, if I look for x is greater than 3, let's put 0 right here. I better, just in case, I better put 0 all the way at the end. Put 0 there, 1, 2, 3. We have 3 there. Greater than or equal to, remember from the last couple days, is at 3 and shading that way. That's where bigger numbers live. Okay. Less than 7, 1, 2, 3, 4, 5, 6, 7, is an open circle at 7 and shaded this way. That's where smaller numbers live. And so when we combine them to give us x is greater than 3 and x is less than 7, we're only shading where these two solutions overlap. So as we can see, if we pull this down, I'd love it if those were grouped, and they're not going to be. Here, let me do it. I want this to work because it helps. And then if I'm able to grab all those, so now I probably need to do the same thing for those, don't I? Give me just 1 second. We can do this, and we'll make it work. Okay, so I've got these two solutions, and we're going to kind of work the same way here. We're going to, when I want to graph the AND statement, 1, 2, 3, I need both numbers that are important, 4, 5, 6, 7, and kind of as scratch work, I think about doing each one individually, okay, where I kind of think that this one's here, and I kind of think that this one's here, and I'm graphing where they're both true. Okay, where this x is greater than or equal to 3 is true from 3 and everything to the right. X is less than 7 is true. Anything less than, not to say it again, but anything less than 7, anything under 7. So open circle and shaded to the left. So the way I graph the intersection is I literally think about overlapping these two. And if I'm doing a little bit of scratch work, if I'm thinking about this in kind of a scratch work idea, I'll think about, okay, this is going to be a closed circle, and I'm going to shade, I didn't really want it to end up that far down, but I'll shade to the right, and then an open circle and shade to the left. I'm going to just shade in where those two overlap. So they overlap from 3 to up until 7, just not including 7. And so that is our graph of our compound inequality. Okay, everything from 3 just up to 7. So let's look at this, and there's actually another way to write this, and we looked at this in a previous problem. Another way that we want to say this is we want all solutions that are between 3 and 7, and including 3 but not including 7. So another way that we can write this is to say 3 is less than or equal to x, which is less than 7. And again, kind of informally, we call that x is between 3 and 7, because literally, as we wrote it here, x is between 3 and 7. Now, you've got to do a little bit more linguistic work, a little bit more verbal work on figuring out where the endpoints count or if they don't count. But there's two ways that we can look at it. We can look at it with an and notation using the word and, or we can look at it as a strung out inequality, sort of a combination of inequalities. And that's why we call it a conjunction. So whenever we have actual equations involved, inequalities involved that we have to solve, we need to solve them first. So as I look at this one, I'll multiply by 6 on both sides, and I'll get r is greater than -6. And on this one, I'll multiply by 8 on both sides, which ends up not really doing anything, but it says r is less than 0. So whenever I'm doing these, I need to know my two numbers. And if they fit on my graph, great. If I've got to do some funky scaling, I'll do that also. For me, just to speed this up a little bit, I'm not going to try to count them out. I'm just going to put the two numbers somewhere. And I think that you can get away with that for the most part. But if your graph's already scaled, then treat it right. Put the numbers where they need to go. This one says x is greater than -6, so I would shade that way. This one says x is less than 0, so I would shade that way. They overlap in the middle. Sometimes you will actually get a compound inequality that the overlap happens over here, that they're both greater than symbols, and it just happens to be on that side. It's in real world application, it's not as exciting, but it's still something that can happen. When we've got it in a compound inequality, most of the time I would say split it up. Write it, split up. That way you can actually feel good about solving it. I'm going to multiply both sides by 2, and I get -8 is less than n, which maybe I like better as n is greater than -8. On the other hand, I have n divided by 2 is less than -1. So when I multiply by 2, having a hard time tonight, I get n is less than -2. So we've got -8 on one side, we've got -2 on the other. They're both not equal to. So again, I keep doing this, and I don't really mean to. I really want to look at one at a time. Okay, n greater than 8 means open circle at 8 shaded to the right, and less than -2, open circle at -2 and shaded to the left. And I shade their overlap. They overlap in the middle. All right, my next one, I've got an and statement, so I can just solve them both. I'm going to divide by -4, divide by -4. Dividing by a negative, remember, makes me flip my inequality. So this is going to be greater than 4, and when I divide by 9, and sure, I could actually look at this and say, all right, I got 4, closed circle, bigger than 4, shading to the right. The only hesitation I might have in doing that right now is I don't know what that kind of operative number is on this one, but I kind of do because I did look at it. And it's less than 8. So, we put 8 somewhere else. Open circle at 8, and that would be shaded to the left. Shade their overlap. That is their intersection. This one, I've got -3 is less than or equal to n over 3. Multiply both sides by 3, and I get -9. And is less than -9 is less than or equal to n, which again, I may want to write that as n is greater than or equal to -9. On the other hand, I've got n over 3 is less than or equal to 1. Multiply both sides by 3, and I get n is less than or equal to 3. And now I have my two numbers. I've got one at -9 and one at +3. The -9 is greater than or equal to, so that's a closed circle, shaded to the right. 3 is going to be a closed circle and shaded to the left, so I shade where they overlap. Next one, I've got a couple things happening, but that's okay. I'm going to subtract 9 from both sides. I have -4a is greater than or equal to, it's going to be -36. That's good because when I divide by -4, I do have to flip my inequality, but I do get +9. On the other one, I have 3a, I'm going to add 6 to both sides, is greater than or equal to -6. Divide by 3 on both sides, and I get a is greater than or equal to -2. So for the first one, I have a is less than or equal to 9. That's a closed circle, shaded to the left. A is greater than or equal to -2 is a closed circle at -2, and shaded to the right, shade the overlap. The only answers that matter are the intersection of those two, or where they're both true. For this one, I'm going to split it up. We're going to say 22 is greater than 7 minus 5p. I'll subtract 7 from both sides. That was supposed to be a 7. Now it is. That gives me 15 is greater than negative 5p. Divide by negative 5. I am dividing by a negative, so I'll flip my inequality. And I'll get negative 3 is less than p. Now I do want to flip that around so it makes a little more sense. Let's say p is greater than negative 3. On the other hand, I have 7 minus 5p is greater than 12. So we'll subtract 7, same process as before. Negative 5p, going to be greater than 5. Sorry, my hand's cramping up a little. I do have to divide by a negative 5, so I'm going to flip my inequality. And I'll have p is less than negative 1. All right, so I've got p greater than negative 3 and p less than negative 1. Sounds like an open circle at negative 3, shaded to the right. Open circle at negative 1. I know that's not a very good scale, but that's okay. Shaded to the left, and I want to shade their overlap. Okay, so a lot of stuff going on there, but those are all and statements, two versions of and statements. If I pull in my same answers from before, because these are the same, I don't want to overdo these. Pull all those in. Actually, they're probably different now that I think about it. I think they are. Okay, that's all right. I'll just do them again. I did flip these around, so that's why they're different. If I think about graphing x is less than or equal to 3, I'm going to put 0 there, 3 there, closed circle and shaded to the left. That's where smaller numbers live. Right, I'm just doing this actually. I'm graphing that whole thing. And if I do the same thing here, 1, 2, 3, 4, 5, 6, 7, I've got 7 right there. That's going to be an open circle and shaded to the right. Now, one thing that we'd run into an issue here, if we were thinking the same as before, we should notice that they don't overlap. Okay, but again, this is an or statement, so it's actually graphing what we call the union of the two, which means we just graph where they're both true. We graph both sets of answers on the same line. I've got 3 there, closed circle, shaded to the left. And I've got 7 here, open circle, shaded to the right. And I don't have to worry about any overlap or anything like that. It's just I'm graphing both of them on the same one, and that's just the answer that we get. Okay? So wherever both of them are true is kind of the, well, that's more like the intersection answer. But yeah, we're graphing where anything is true. And those could be our answers. Because think about the statement. X is less than 3 and less than or equal to 3, or x is greater than 7. I could use something like 10. Sure, it doesn't work in both of them, but 10 is bigger than 7, so that's okay because of the word or. Versus if this said the word and, we don't have any overlap, so we wouldn't have any numbers that work for both inequalities. Okay, so it's kind of backwards to the and statements. Sadly, we don't have any quick way to write an or statement like we do with the and, kind of combining them into a string of inequalities. We don't have that here. So every one of these you'll see or, and this should say disjunctions. They are disjunctions, just to use our vocabulary right. I just copied and pasted it and I didn't even proofread it. How bad of me. Here I'll subtract 10 on both sides. I'll get p is greater than 2. And then I'll add 1 on both sides here. And I'll get p is less than 1. This is actually a pretty wide range of answers. If I have 1 here and 2 here, I've got an open circle at 1 and shaded to the left for less than 1. On this one, I have an open circle at 2, shaded to the right of 2. And that's our answer. We don't need to worry about an overlap, don't need to worry about anything. And what it turns out to be is only the numbers between 1 and 2 do not work. And that's like an inclusive, like 1 doesn't work, 2 doesn't work, and anything between them doesn't work. But anything outside of that realm would work just fine. Next one, we're going to divide by 9 on both sides. I'm going to get x is less than negative 10. I didn't divide by a negative, so I don't have to worry about that. On this one, I'm subtracting 7 on both sides. I get x is greater than negative 5. So anything less than negative 10 and greater than negative 5. Both open circles and shading in opposite directions. Most of the time, and I do very loosely say most of the time, and statements will overlap and or statements will go away from each other. That doesn't mean that's going to happen all the time. I'm just saying most of the time that's going to be the case. So this one I'm going to multiply both sides by 9. So b is going to be less than or equal to negative 9. And also, or if I add 3 to both sides, b is going to be greater than or equal to negative 7. So I'm going to have negative 9 and negative 7. Again, not a great scale, but that's okay. You can work harder on that if you want to. This one would be closed circle at negative 9, shaded to the left. This one would be closed circle at negative 7 and shaded to the right. I'm just graphing where either of them work. Should have probably used that word in the definition, either. Because it is. It's a solution where either thing could happen. Right? And again, when we get to kind of this level of math, we are talking about solutions. I'm not really talking about answers. Because to say that there's one answer, there's really not, because there's not one number that works. Okay, we have a multitude of numbers that work, but we're trying to show everything that works. This one, if I solve both sides, notice I multiply both sides by 2 on that one, subtracting 3 on this one, and I get everything less than 0 or greater than 10. So I could say 0's here and 10's all the way over here. Less than 0, that's numbers like this. Greater than 10, that would be numbers over here. All right, so compound inequalities are something they seem difficult because there's a lot of stuff going on, but they actually work out pretty nice. On this one, I'm going to add 8 to both sides, and then I'm going to have to divide by 8. I see that coming. Negative 24 plus 8, that's going to be negative 16. I'll divide both sides by 8, and I'll get x is greater than negative 2. On the other one, I'm going to subtract 9 on both sides, and I get negative 4x is greater than 12. Divide by negative 4. Now I am dividing by a negative, so I'm going to have to flip my inequality. Less than negative 3. So I need everything less than negative 3 and greater than negative 2. Right? I got negative 3 there. I'm going to spread them out a little bit. Negative 2 there. So those are my two operative numbers. Greater than negative 2 lives over there. Less than negative 3 lives over there. And that is the set of solutions that works on this problem. Last one we've got here, I'm going to subtract 10. Got a lot of stuff happening here. Less than negative 7r is less than or equal to 28. Divide by negative 7. We get r is, I divided by a negative. Got to flip my inequality. Sometimes it sneaks up on me too. Greater than or equal to negative 4. On this side, we'll add 7 to both sides. They're going to make me think, aren't they? 3r is less than negative 27. Divide by 3. And I get r is less than negative 9. So we've got less than negative 9. Greater than negative 4, greater than or equal to, less than negative 9, Less than -9 is open circle at 9 and shaded left. Greater than or equal to -4 is closed circle at -4 and shaded to the right. Got through a lot of problems today. I know it took a little bit longer, but yeah, these problems do take a little bit more time. So make sure you get any questions down. Otherwise, I hope you have a great day, and we will see you in class.